Hello, gardeners. Welcome to the Living Soil Lab. For generations, compost has reigned supreme as the gold standard soil amendment. The one thing every gardening expert agrees will transform your beds and supercharge your plants. But what if I told you that something you're probably throwing in the recycling bin every week could rival or even outperform traditional compost in building soil health? Today, we're conducting a head-to-head experiment that pits finished compost against shredded cardboard in identical garden beds. And the results might completely change how you think about feeding your soil. This isn't about replacing one with the other, but understanding what each material actually does and when you might choose one over the other for specific garden goals.
Understanding what each material brings to your soil is key. Traditional compost is decomposed organic matter that's already been processed by microorganisms, transforming kitchen scraps, yard waste, and other materials into a dark, crumbly substance rich in available nutrients and beneficial microbes. When you add finished compost to your garden, you're introducing both nutrients that plants can immediately access and a diverse community of bacteria, fungi, and other organisms that continue working to improve soil health. Compost typically contains balanced NPK ratios, beneficial minerals, and humic substances that improve nutrient retention. It's biologically active material that jumpstarts soil food web activity and provides immediate fertility. Cardboard, on the other hand, is primarily cellulose and lignin, complex carbon compounds that haven't yet been decomposed. When you add shredded cardboard to soil, you're not providing immediate nutrition, but rather creating habitat and food for soil organisms while dramatically improving soil structure. Cardboard acts as a sponge, absorbing and holding water while creating air pockets as it begins breaking down. The decomposition process feeds fungal networks particularly well, as fungi excel at breaking down the tough lignin bonds in cardboard. This high-carbon material also serves as a long-term carbon source that builds stable soil organic matter, the kind that persists for years rather than seasons. Understanding these fundamental differences helps explain the results we observed in our side-by-side trial. So, to conduct a meaningful comparison, we set up 3 identical raised beds in full sun, each measuring 4 feet by 4 feet. We filled them all with the same base soil mixture, which we intentionally depleted, just to create a level playing field. Bed 1 received 4 inches of finished compost, worked right into the top 6 inches of soil. Bed 2 got an equivalent volume of shredded cardboard, also incorporated into the top 6 inches. And Bed 3 served as our control, receiving only the base soil, with no amendments at all. We chose fast-growing radishes for this experiment because their quick growth cycle lets us see results pretty fast, and their development above and below ground gives us clear signs of soil health and nutrient availability. All 3 beds received identical treatment in every other respect. We used the same radish variety, planted seeds at the same depth and spacing, on the same day, and maintained consistent watering schedules using drip irrigation to ensure even moisture distribution. The beds were positioned side by side, so there were no variables related to sun exposure, temperature, or wind. Every week, we documented growth with photographs, measurements, and detailed observations of plant vigor, leaf color, and any signs of nutrient deficiency or pest pressure. This controlled approach, honestly, ensures that any differences we observe can be confidently attributed to the soil amendments, not environmental variables. Within the first week, some dramatic differences started to show up, and honestly, they really challenged our expectations. The compost bed showed the earliest germination, with seedlings breaking the surface a whole day before the other beds. That makes perfect sense, since compost provides readily available nutrients that fuel rapid initial growth. But then, by week 2, something interesting happened. While the compost bed plants were taller and had darker green foliage, the cardboard bed seedlings, though a bit smaller, displayed remarkably robust, thick stems and leaves with a different quality of green, suggesting excellent chlorophyll production, even with slower initial growth. The control bed, meanwhile, lagged way behind both amended beds, with pale, spindly seedlings struggling along in that depleted soil. By week 3, the gap between the compost and cardboard beds was narrowing in some unexpected ways. The compost bed plants kept their height advantage and lush appearance, producing the kind of rapid, vigorous growth we usually associate with high fertility. But the cardboard bed plants, while still a little shorter, were developing noticeably more leaf mass and showed exceptional disease resistance. Not a single plant showed the slight mildewing that appeared on a few compost bed specimens. Most intriguingly, when we checked soil moisture levels, the cardboard bed retained significantly more water, even though all beds had identical irrigation. It stayed evenly moist, while the compost bed showed more variation between wet and dry zones. That improved water retention meant the cardboard bed plants experienced less stress and more consistent growing conditions. At 4 weeks, we pulled our radish crop, and the results told a nuanced story that, honestly, defies any simple winner-takes-all conclusion. The compost bed produced the largest total yield by weight, with radishes averaging about 20% heavier than those from the cardboard bed. The tops were lusher, roots were larger, and overall, biomass production clearly favored the compost treatment. So, if your goal is maximum production in minimum time, compost delivered exactly what we'd expect. However, when we looked closer at the quality of the harvest and the soil itself, cardboard revealed some hidden advantages. The radishes from the cardboard bed, while a bit smaller on average, showed superior uniformity with almost no splitting or deformity, issues that affected about 15% of the compost bed harvest. More dramatically, when we dug up root systems, the cardboard bed revealed something remarkable. Root development was significantly more extensive, with fibrous roots reaching 8 to 10 inches deep, compared to just 6 inches in the compost bed. The soil structure in the cardboard bed had transformed dramatically, becoming incredibly friable with visible aggregation and a spongy texture that the compost bed just didn't match. Most striking of all was the visible fungal mycelium threading through the cardboard bed soil, creating exactly the kind of biological structure that signals long-term soil health, not just immediate fertility. The real truth this experiment revealed is that compost and cardboard aren't really competitors. They're complementary amendments that serve different purposes. Compost is fantastic for providing immediate fertility, jump-starting microbial populations, and giving you maximum yields in the short term. If you're prepping beds for heavy-feeding crops like tomatoes or squash, or you need to quickly remediate depleted soil, compost gives you immediate results that cardboard just can't match. The nutrients are right there, available now, ready to fuel rapid plant growth without waiting for decomposition. Cardboard's strength, on the other hand, lies in building lasting soil improvements that really compound over time. The superior water retention means you'll need less irrigation and get more consistent growing conditions. The dramatic improvement in soil structure creates better root penetration, improved drainage, and resistance to compaction that will benefit future crops for years. The fungal dominance that cardboard encourages creates the kind of soil biology that suppresses diseases and builds stable organic matter. For perennial beds, pathways that'll become growing areas, or any situation where you're building soil for the long haul rather than chasing immediate yields, cardboard offers advantages that finished compost just can't provide. So, what's the practical takeaway here? The most powerful approach combines both materials strategically. Use cardboard as a base layer or long-term soil builder, working it into beds months before planting, or using it as sheet mulch to decompose in place. Then, layer compost on top for immediate fertility and to speed up the decomposition of the cardboard beneath. This combo gives you both immediate nutrition and long-term structural improvements, creating soil that performs well now and just keeps getting better with each season. In pathways, pure cardboard mulch builds soil while suppressing weeds. In annual vegetable beds, a cardboard base topped with compost gives you the best of both worlds. For gardeners on tight budgets or in places where compost is pricey or hard to find, cardboard is a nearly free alternative that builds genuine soil health instead of just providing short-term fertility. The water retention benefits alone can really cut irrigation costs, especially in dry climates. And for those who care about sustainability, diverting cardboard from recycling streams while building soil carbon is a real environmental win. The key is understanding you're investing in long-term soil development, not just expecting instant results. So, Subscribe to the Living Soil Lab for more side-by-side experiments, soil building strategies, and evidence-based approaches to creating gardens that get more productive every year. Share your own cardboard and compost experiments in the comments, and let's build a community of gardeners who know the best soil amendments might already be sitting in your recycling bin.